Good morning everyone. I am K. Manjula, Assistant Professor in Physics Department. Today we discuss about Davisson and Germer's experiment. Davisson and Germer first detected electron waves in 1927. They have also measured de Broglie wavelengths of slow electrons by using diffraction methods. Principle of Davisson and Germer's experiment. Based on the concept of wave nature of matter, moving electrons behave like waves. Hence, accelerated electron beam can be used for diffraction studies in crystals. This is the experiment setup of Davisson and Germer's experiment. They did experiment under the vacuum chamber, under the vacuum tube. Here, they consider that filament, and opposite of filament arrangement, it has nickel crystals. It acts as a target, and here, in the bottom of that semicircular scale, a detector chamber is there. The detector chamber is connected to galvanometer. Experimental arrangement. The electric gun G produces a fine beam of electrons. It consists of a heated filament F which emits electrons due to thermoionic emission. The accelerated electron beam of electrons are incident on a nickel plate called target T. The target crystals can be rotated about an axis parallel to the direction of incident electron beam. The distribution of electrons is measured by using a detector called Faraday cylinder C, and which is moving along a graduated circular scale S, a sensitive galvanometer connected to the detector. The result of the experimental setup, when the electron beam accelerated by 54 volts was directed to strike the nickel crystal, a sharp maximum in the electron distribution occurred at an angle of 50 degrees with the incident beam. For that incident beam, the diffracted angle becomes 65 degrees. For the nickel crystal, the interplanar separation D is equals to 0.091 nanometers. From experiment graph, scattering angle on x-axis and current is on y-axis. At 50 degrees, it gives the maximum of scattering of electrons per 54 volts. According to Bragg's law, 2d sin theta is equals to n lambda. Here, 2 into d is the interplanar separation, 0.091 into sin 65 degrees is the incident angle, is equals to n lambda. Lambda is equals to 0.165 nanometers. For a 54 volts, the de Broglie wavelength associated with electron is given by lambda is equals to 12.26 by under root V. 12.26 by under root of potential energy 54. Lambda is equals to 0.166 nanometers. This is an excellent agreement with the experimental value. The Davisson and Germer experiment provides a direct verification of de Broglie hypothesis of the wave nature of moving particle. Variation of galvanometer current with variation of angle theta between incident beam and beam entering the cylinder is shown below. Different potential energies, variation of scattering of angle graph. These are for 44 voltage and 48 volts and 54 volts and 60 volts. Graphic representation for scattering of electron.